here's the work in progress. I've got some bolt holes drilled and tapped through to attach the AC compressor clutch material onto the SC14 clutch spring. So this can fit directly onto the SC14 shaft. And once the bolts are out of the way, I'll be able to test fit it onto the pulley. Alright, so I finished sawing these bolts clean off, and kind of made a mess of it in some of these, but you know, that's at least 3/4 of the friction material I'm looking for. Now I have the friction material that is designed and mates with the pulley, and when I power this up, we got our 51 watts. I am no longer able to get this to budge at all. And the cherry on top is that the gap between the friction material and the pulley, when it's installed with the Supercharger shaft, looks about like this. There's just that little bit of a gap, thanks to how the shaft sits on here. So I'm very hopeful that this does exactly what I need it to. With such a small gap, I also think it'll be fairly reliable with a fairly high clamping force. Alright, so I'm going to start on the pulley swap. So here I'd like to comment on why I'm going ahead with the smaller pulley swap, even though I haven't yet upgraded the car's fuel system. Like, am I really expecting the car to run right with 7 pounds of boost and not blow up, etc.? It was more to do with all of my bench testing of this like custom pulley design, where I had to, you know, put the AC compressor clutch onto the existing clutch mechanism and spring. Just this whole stack of additional steps and having to MacGyver things made me more and more concerned that when I finally did put this smaller pulley in, something wouldn't work right. I might have that clutch start slipping. I might notice that I need to run more power through that electromagnetic coil in order to maintain the right boost pressure. I wanted to find all of this before I went through the effort of upgrading the fuel system, so that I could start fixing these issues sooner. So here you'll see me actually replace the pulley, take it out on the road, and actually see what boost pressure I'm making with this new smaller AC compressor pulley. A lot of gunk, but yeah, under the flange it looks pretty good. Okay, magnet is plugged in, wired up. Next is the pulley. There we go. I got it reinstalled without the shim. And that clearance is more what I expected. Pulley can still spin freely. And yeah, at this point it's fully reassembled, just the belt left to go. This is the original like 102.5 inch belt, and it almost looks like it's in the same spot for the tensioner, so I think it'll work fine. And yeah, I think we're ready for a test drive. Okay, just went for the very first drive with no tuning changes with the smaller pulley. And I did notice an increase in boost, but not nearly the increase I expected. Instead of jumping up to like 7 psi from 3.5, I'm seeing maybe just a peak of 4.5 psi. That's still a healthy increase in power. So yeah, I'm going to adjust the tune to add a bit more fuel, go for another drive, look for anything weird. So the only change I've made is in these cells, I've made the mixture a bit richer. So once this is done flashing, let's see what difference that makes. Alright, so I've got a half decent tune ready. I want to take another 0 to 60 run, this time at the 4.5 pounds of boost. So let's see what we get. Okay, so since with the smaller pulley I'm getting less boost than I expected, I want to rule out different sources of boost pressure loss, like belt slip or clutch slip. Okay, so I'm going to mark this section of pulley and this section of clutch. Okay, installed. That looks like slip to me. The clutch is locked, but they're completely opposed. Huh. So, yeah, it's a failure of the clutch, it seems. Here is the clutch removed. How much of that marker wore away on the pulley. So as a next approach for reducing clutch slip, I've got the small motorcycle clutches, and I'm going to take one of them and rivet onto the original SC14 pulley. The clutch is now secure to the pulley. Curious. So it's like it doesn't want to be perfectly centered. Interesting. Alright, so testing the clutch connecting to the pulley. I had to tighten it down so that it was... So essentially the Supercharger tries to be always on plus some slip. So kind of the worst of both worlds. Taking the clutch off, I see that it really only contacted in one narrow strip around the outside edge of that pulley. So that may be a big part of the reason this didn't work. Yeah, I mean, it would be interesting to try two similar clutch faces facing each other, but I just don't have any trust in the magnet pulling them together with enough force, especially since the heavy steel plate would be so far away, combined with the fact that the clutches seem to be doing weird things in this magnetic field. All right, one last Hail Mary attempt at something that works with the clutch before moving on to a fixed pulley. Once I go fixed pulley, it really doesn't matter what these current clutch surfaces look like. I'm probably going to use these two since they are the right size, they mate together. This one's already been modified significantly. So my one last Hail Mary attempt is going to be to cut a bunch of actual grooves, like slots, radially throughout this whole thing, and also throughout this whole thing, with the hope that when the clutch engages, they interlock rather than relying on friction between these two surfaces. So now I've notched kind of the different sectors that I want to cut out. Okay, so machining complete. Here's what this looks like. I have absolutely no idea if this will work. I'm pretty sure it won't sound good. I hope I can still bolt this on and haven't damaged the threads too much. So yeah, let's try this out. Alright, it's back together. So despite the machining, the gap is pretty nice between these two surfaces. No need to add more washers or anything. So yeah, moment of truth is going to be starting it up, engaging the clutch, and cringing at the grinding sound that's going to follow. So I've just started it up with not enough shims to fully space these guys. So you can hear the Supercharger running even when it should be off. And when I force it to use the Supercharger, well, this amazing sound. So, not great. So I've officially thrown in the towel on a clutched Supercharger pulley. I have disconnected power from the magnet and removed the magnet. The pulley face, the clutch is now bolted directly to the pulley. So big question now is just how much boost this makes, and then I'll go from there. Alright, it's a new day and I'm trying a shorter 6K 1015 belt just to see if it's a belt tension or a belt slip issue that's leading to less boost than expected. Here, this peg represents where we are in the tensioner. I think we're about 2/3 of the way on. This is probably the shortest belt I'd want to use with the current setup. So let's see if it makes more than like 4.5 pounds. Here's a measurement of the original pulley at 110 from the edge of the inner ribs to the edge of the inner ribs. And here I'm trying to measure the diameter similarly for the new pulley. The access is a little bit worse. I should probably get longer jaw calipers at some point. But the reading is, it's like 104-ish, maybe smaller by a few percent. So that, in the end, explains all of these struggles. Feel kind of dumb for mutilating it in the pursuit of eliminating clutch slip, but in the end, it's just the fact that this pulley isn't that small. So I'll post the like calculations for how much, I don't know, let's call this 104 millimeters, how much boost a 104 millimeter pulley should make, and then I think I'll just resume my quest for a 93 millimeter pulley. All right, so yeah, stay tuned. Thanks for watching.